Before reinstalling the drum, make sure the mating surfaces are cleaned with a wire brush. Pay particular attention to the edge of the center hole where the drum contacts the hub. Remove all foreign material with a clean shop towel. Once all of the components have been properly inspected and cleaned, apply a light coating of corrosion inhibitor to the pilot pads, and then position a pilot pad at the 12 o'clock position so the brake drum can be centered on the hub. With the pad properly positioned, get the help of another technician or use the appropriate brake drum dolly to install the brake drum. All of the mating surfaces on the wheels must be cleaned with a wire brush and inspected before they can be installed on the vehicle. If any damage or cracks are visible, the wheel must be removed from service and scrapped immediately. Welding on a rim or wheel will change the properties and strength of the metal. Never apply heat or weld on a wheel, especially when the tire is still mounted on the rim. The temperature of a welder can reach 11,000 degrees Fahrenheit or 6,000 degrees Celsius on contact. While as much as 50% of the heat is lost through conduction, the surrounding metal is still heated to extremely high temperatures, which ultimately heats the air inside the tire. When the rubber inside the tire reacts to the heat, it generates gases that can lead to an internal fire. Eventually, the rising heat and pressure becomes too great for the tire and rim to contain. While the internal changes will not be apparent to the outside observer, the severe increase in temperature and pressure will cause the tire and wheel to catastrophically explode without warning.
Remember, it is an OSHA violation to apply heat or weld on a wheel or rim. When you weld on a wheel or rim, you're placing yourself and others around you in imminent danger, especially if the tire is still mounted. If a repaired wheel or rim fails, experts will agree that it should have never been repaired in the first place.
The same holds true when using an acetylene torch to cut off damaged fasteners. Heat from the torch is transferred to the studs, wheels, and hub, which can cause irreversible damage to the components, such as melted wheel bearing seals or burned tire beads. That's why technicians must carefully clean and inspect all of the components, including the studs and fasteners. Always look for any damage, corrosion, or wear before installing the wheels. On hub-piloted wheel assemblies, apply 2 to 3 drops of 30-weight oil on the last few threads of each stud and between the nut body and the flange. This will help ensure the proper clamping force can be reached. Before attempting to install the inner wheel, position a pilot pad at the 12 o'clock position. Make sure that excess corrosion inhibitor material is not trapped between the inner wheel and the brake drum, and then carefully install the inner wheel. Double-check the mounting surfaces of both wheels to ensure there is no dirt, rust, or foreign material that will be trapped between the two wheels. Under operating conditions, disc wheels continually flex as they adapt to the weight of the vehicle and cargo. When debris is present between the mating surfaces, joint settling can result in a severe loss of clamping force. The reduction in clamping force ultimately results in loose wheels, which can cause a wheel-off incident. To prevent severe joint settling, always make sure the mounting surfaces of the wheels are clean and free of any dirt, rust, corrosion, severe pitting, burrs, paint runs, or any other foreign material. If the mounting surface does not appear to be flat and in good condition, scrap the wheel immediately. When installing the outer wheel, align the hand holes so the inner valve stem is accessible from the outside and opposite the valve stem on the outer wheel. Seat the wheels on the hub as far back as possible, and then hand tighten a fastener at the 12 o'clock position to make sure the outer wheel is completely on the pilot pad, and then hand tighten each of the remaining fasteners a few turns.
The final step of the process is to apply the proper amount of torque to each fastener in a star pattern. This will help ensure that the clamping force is sufficient and evenly distributed around the hub.
While there are many different methods for tightening wheel fasteners, the most accurate approach has traditionally been the manual torque wrench. Torque wrenches are often considered labor-intensive, but they are very reliable and accurate tools that ensure the proper torque is applied to all wheel fasteners. However, there is a new breed of pneumatic nut runners that combines some of the speed associated with the impact wrench with the precision and accuracy of the standard torque wrench. In some instances, these gear-driven tools require a special air regulator or a minimum air pressure in order to operate correctly. These tools shouldn't be confused with standard air-powered impact wrenches. Impact wrenches utilize a hammer mechanism that are not considered torque control devices, so they should not be used to set the final torque. However, impact wrenches can be used to snug the nuts in a star pattern to ensure the wheels are properly seated. Whatever method is selected, the end result on disc wheels must be 450 to 500 foot-pounds of torque on each fastener. While the effects of under-torque are obvious, over-torquing the fasteners can be just as dangerous. When torque is applied to a fastener, the stud is stretched slightly under tension, but returns to its original dimensions when the fastener is removed. When excessive torque is applied, the stud is stretched too far, which results in a weakened stud that can fail during service. On a hub-piloted flange nut, just 2 seconds of impact time with a 1-inch impact wrench can result in almost 700 foot-pounds of torque, almost a 50% increase over the recommended torque of 475 foot-pounds. But technicians must still remember that the correct torque does not guarantee the correct clamping force if the components are in poor condition or improperly installed. That's why it's important to always check fastener torque after the first 50 to 100 miles of service. On disc wheels, the best practice is to set the torque wrench at 475 foot-pounds and then attempt to tighten each of the fasteners. If none of the fasteners move in a tightening direction before the wrench clicks or the handle breaks, then the torque is at least 475 foot-pounds. If the fasteners show slight movement in a tightening direction before the wrench indicates 475 foot-pounds during the torque check, then the assembly should be inspected for any other signs of loose or damaged components. If the fasteners experience significant movement before the wrench clicks or the handle breaks, then the wheel should be completely removed from the axle so all of the components and mounting surfaces can be carefully inspected. When a wheel-off occurs and the assembly strikes another vehicle, the resulting impact can be devastating to the driver and any passengers. In this controlled test, a standard low-profile truck tire strikes a stationary vehicle at approximately 55 miles per hour. The vehicle is moved almost 4 inches, and the damage to the driver's door and door jamb is significant. After colliding with the vehicle, the inflated tire was launched over 20 feet in the air and finally came to rest 100 feet in the opposite direction.
As you can see, the risk associated with wheel-offs and wheel-end fires are very real. By following the recommendations in this video and implementing a wheel-end maintenance and safety program, we're confident that fleets can reduce the chances of an accident and improve wheel-end performance. On behalf of Michelin North America and the Tire Industry Association, I'm Doug Jones. Thanks for watching.